And we're going back. All right. Hi, everyone. Again, thank you, everyone, for tuning in to DetaPipe Improved Reliability for Reactive Metal Piping. My name is Haley Ryersford, and I'll be your moderator today. This webinar will last for about 20 to 30 minutes. All attendees are on mute, and we will take questions at the end of the discussion. There will also be an opportunity to request more information at the end of the presentation. Now I'm going to hand it off to Edgar Vidal, Vice President of Business Development, Vice President of Business Development and Marketing.
Thanks, Haley. Today we're happy to present our work on DetaPipe, and we have Jason Carter here, who's the Global Director of Sales. He's been with the company for 15 years, I believe.
In fact,
and it's an exciting time for the company, and who better than Jason to tell us more about this product.
yeah, thanks, Edgar. Welcome, everybody. Thank you for joining today. And like Edgar said, this is kind of a big day for us. In our storied history, we don't often and have not often launched actual new products. We've done different cladding combinations over the years, but an actual product is not something that we've done on a regular basis. But before I talk about DetaPipe, I wanted just to bring everyone who's on the call up to speed with what has happened over the last 60 years here at NobelClad. If you go back in our history, the evolution of the American chemical market and the global chemical market to lean more and more on the polyester value chain has only increased. Dating back to our very beginnings as a company, the need to clad things like zirconium and titanium were always there. Titanium and zirconium are two metals, reactive metals that are great at resisting a lot of the high pressure, high temperature, corrosive environments needed in producing things like PTA, acetic acid, which are part of the PET value chain, and other derivatives like that. Ideally, people would just design out of one metal.
Right.
Titanium, zirconium are proven to withstand the corrosion environments, as I said. But the problem has always been they're expensive. And if you need to make an entire pressure vessel or reactor out of these materials in solid construction, it'd be extremely expensive. So early on, NobelClad got our experience in offering titanium and zirconium clad for these high pressure chemical applications.
Right.
In that time, which was about the 1960s, our plates went into service, and they have in fact lasted for decades. And going forward, in the 1980s, NobelClad worked with some of our raw material suppliers like ATI to even tailor the alloys ideal for the corrosion environment to be a lot more suitable for the explosion cladding process. So what that enabled us to do was make even larger clad plates. In fact, the world's largest titanium and zirconium clad plates are available at NobelClad, the DetaClad product that we still sell today. And those reactors and vessels, from the 60s and all the way through the 80s, many of them are still in service today. As the processes have gotten bigger, the economies of scale have needed to improve. The end products, PTA, PET, have become commoditized. So being able to do all this stuff cost effectively has always been on the forefront of why we need to be efficient as a clad producer and raw material supplier.
So what you're describing is taking the solid reactor and essentially providing a clad
Correct.
solution where the amount of that refractory metal is a lot less at
Correct.
the end of the day.
Yeah, clad exists first for the cost benefit. You want to use the minimum amount of those raw materials as possible,
Okay.
rather than use it as a full solid construction for the pressure equipment.
Understood. Yeah.
Okay, so why are we where we are today? Well, all those pieces of equipment which are in existence have always needed to be connected with some type of piping solution, right?
Okay.
Over the years, to address some of those needs, to transfer the chemicals from one vessel to another, people have leaned on things like PTFE or FRP line solutions, loose lining, or even a worst case, solid. And all those come with different degrees of fit.
Mm-hmm.
PTFE, FRP line products are good, but if you have high erosion environments, for example, I think most people that end up using those find themselves replacing them probably on a more regular basis than what they would like. Anytime you're replacing it, your downtime, there's a cost,
Right.
there's things like that. You could look at loose lining. Loose lining is very widely used in the chemical process industry today. There's a lot of tantalum line equipment out there. It's very, very cost effective, but likewise somewhat limiting in its performance capabilities for different chemical processes.
Right.
Because it's loose, there is air in between the cladding layer and the pressure boundary of the pipe. So things like heat tracing aren't really efficient or possible in some cases. Further, if you have to use them in, not vacuum, but at actual pressure and temperature, there can be differential coefficients of thermal expansion between the two metals, enough that when you weld the end of the liner to one end of the pipe to the other, you actually get the end of the pipe to crack,
Actually correct. Right.
which is not good.
Okay. Yeah.
So, I think in some cases, like I said, loose line is used widely. It's a solution. I think people find it suitable. It's cost effective, but is something better available. And if loose line doesn't work, worst case, you go back to the solid alloy. I mean, you can fabricate pressure equipment from solid materials when you need to.
Right.
Some of the materials out there for construction, because you need the high reliability and the high corrosion resistance of the different materials, you land on things like alloyed versions of titanium and alloyed versions of zirconium to increase the strength and reduce the wall thickness of the metal.
Yeah.
The metallurgical processing of those materials can be problematic. Small inclusions, impurities of the ingots, when they get rolled out in a raw form, only get worse when you go to fabricate them, and then can even be catastrophic if they get into service. And so things like welding solid zirconium 705, for example, can be tough because you run the risk of having what you see on the screen there is delayed hydride cracking occurring.
Right.
In pipe design, you'd like to have everything available as seamless because you get the full credit for the strength of the material without a weld. But in a lot of the alloys, seamless options aren't available above 12 inches, for example. And at the end, you're still paying a lot of money for some of these materials to be used in that service.
Exactly. So like you said, zirconium has issues with potential hydriding in the manufacturing. Titanium, for example, has problems with homogeneous distribution of the alloy elements.
Correct.
Which again, if you're making a thick pipe, then that could be a problem.
Yeah, I mean, not only are you relying on it to perform from a corrosion perspective, but you're leaning on those alloy elements for the strength.
Gotcha. Okay.
So
Understood.
if it's not done well,
Right.
there's a potential for failure there.
Okay. So what's the solution? And I guess that's why we're here.
Great question. That's why we're here. All right. So I think what you'll see on the screen now is what we call DetaPipe. Okay. The version you see there on the screen is called DetaPipe ZR, which means it's a pipe clad with zirconium.
Okay.
Okay. That system from end to end, the flange face all the way through and to the far right is fully clad with zirconium within a carbon steel pipe spool. Okay. So this is our attempt at trying to get the industry exactly what they wanted. For reactive metal pressure vessel fabrication, DetaClad was a great solution because it's high reliability, it's good strength, it literally lasts for decades. DetaPipe, we believe, is going to be the same thing for the piping pressure transfer of the chemical process medium. So if we go into more details on DetaPipe, number one, we always ask ourselves, well, can we clad it?
Correct.
At NobelClad, we love the challenge of trying to clad virtually any raw material that's out there. But being able to clad it is one thing. Ensuring that it actually withstands the suitability of the application is the second, and frankly, the most important part. So when we started with DetaPipe, once we got the cladding process dialed in, we took it immediately to, okay, well, what are people going to want to know? What can it do?
Right.
Well, the only other clad solution out there is loose lining, in some ways. Loose lining does not bode well for thermal cycle and fatigue failure modes. So the first thing we did was we tested our pipe at 225 degrees C and up to 260 bar G And in the straight section, we actually cycled it up and down 5 times. Okay, well, do we get any cracking at the surface? And the answer to that was no. And then some of the folks we were working with in the development of this product said, well, I mean, I would like to know what's the life cycle fatigue failure for this product. And so we said, okay, let's do some FEA, identify where the potential weakest part of the product is.
Right. Yep.
Let's put sensors all over that and then test the crap out of it. And so in the straight section, we actually went through and took that piece through about 1,000 cycles of thermal cycle testing.
Okay.
At the end of that, in phase array inspection, there was 0 cracks, there was 0 crack initiation.
Mhm.
In some ways, that's great. The product withstands a very long life. In other situations, it's not great because you really didn't define, well, where is it going to fail?
Right.
I mean, everyone knows in pipe design, there will always be, in fatigue, there's always going to be a failure. So then we took it a step further and looked at the elbow solution
Mhm.
and said, okay, let's make an elbow and then do the same thing. And that we did back in January. We put it in test,
Okay.
same kind of temperature ranges, took it up and down, high temperature, back down, pressurized it, inspected it every couple of 100 cycles. And that has been running since January, still without any crack or
It's
failure.
still running today.
Still running today.
Okay.
And right now we're at 1,500 plus cycles.
Okay.
And one of the things that someone may say is, well, okay, why don't you guys just make clad pipe from DetaClad,
Mhm.
right? Roll and weld it
Exactly,
into a
right.
pressure component.
Yep.
Well, you can. The diameter's got to be big enough. Like in the pressure vessel fabrication, you have to go in and roll and weld the pressure vessel, make the pressure boundary weld, strip back the cladding, obviously, before that, and then do what's called a batten strip. Okay, the batten strip can be recessed or proud or otherwise. In pipe fabrication, you can technically make it out of DetaClad,
Right.
but it's got to be a large enough diameter that someone can get in there
Mhm.
and actually do the weld, and you can do the inspection. It's not going to have any issues. But secondarily, if you have any issues with erosion, the proud batten strip to the surface of the cladding could also create another erosion failure site. So that would not be good. So yes, technically you can make DetaClad into pipe at 30 inches and above. Anything less than that would probably be unsafe and probably not suitable.
Okay. Understood.
So recognizing that, probably one of the biggest bangs for the buck, I'm sorry, in the next slide, folks may say, well, we're used to you guys offering very reliable clad plate.
Mhm.
Okay, well, one of the things we did is we cut the pipe apart destructively, and we wanted to ensure that there was good gripping force between the pressure boundary wall and the cladding layer. And so we did that. This was actually a sample of, you can see on the OD, the carbon steel, and on the ID, the zirconium liner. And we actually did some push-out tests with that. And even at high temperatures, we have good locking force of the cladding to the pressure boundary.
So just to be clear, what you're seeing on the screen, what's the inside? The inside is that titanium
Yeah,
clad or zirconium
yeah,
clad?
zirconium or titanium, correct. And then the OD is carbon steel.
Okay. And you mentioned before about bends for the fatigue testing. So can you tell us more about that?
Yeah.
What's possible?
Yeah, so
in DetaPipe?
obviously, if you have a large plant and there's long lengths of run, the first thing you want to kind of look at is how do I replace these long sections of alloy with
Okay.
clad? So straight pipes, possible. Then what about elbows? Okay, well,
Right.
elbows was the next challenge. So we did take that to the next step in our development and actually prove that we can make 90-degree elbows.
Okay.
Now for the initial design, we started off with the 10D bend. But at the end of this and the evolution of how we developed the product, not only doing a 10D bend, but getting down to the 1.5D bend would be critical.
Mhm.
Because I think that's relatively important for the market. It allows you to design more bends and things within a smaller real estate of the actual skid or the plant.
Right.
So, for us, we've done the elbow production. We've now tested that in cycle fatigue testing, and that proves very robust. So where do we go from here, right?
Exactly. Yeah.
That's great. Eventually you're going to have to do other branch connections and things like that. So currently in development, in production, we have a 1.5D bend in process that we're developing.
Okay.
We're looking at how do we clad for branch connections or T's.
Okay.
So that at the end, some guy can go in and design the entire thing out of DetaPipe and get everything he needs to be able to transfer the chemicals throughout the
So you said something that's critical, right, for the engineer is, okay, I'm going to design with DetaPipe now. We have T's, elbows, straight spool. Is there a specification that we can call to, or how does that work?
Gosh, it's like we rehearsed this thing. Right?
Yeah.
So if you go to the next slide, NobelClad, much like we did with our DetaClad process, we've got, in that sense, we have DMC 100.
Okay, right.
In DetaPipe, we created Deta 221. Deta 221 is a specification that looks at all the things that someone would need to send to us and say, I would like to buy DetaPipe to ensure it's manufacture, fit, form, and function for my application. It lists here are the tests we're going to do, how we're going to manufacture it, how we're going to certify it, what comes with it, things like that. And I think in the end, not only are we offering a very technical, reliable solution, we're making it very easy. I mean, at the end of the day, DetaPipe is a carbon steel pipe spool. We just line it with titanium and zirconium through our cladding process. And so it makes it easy. As long as you're designing your piping to ASME B313,
Okay.
DetaPipe is going to be a drop-in for you. And currently, if you go out and look at different specs, ASTM, ASME have been for pressure vessel boiler codes have gone through code case and things like that to say, yes, when you use clad in a pressure equipment, these are the things you have to certify to. So you have B898, A264, things like that. There's nothing that exists like that right now for DetaPipe.
Right.
So Deta 221 is the first step, but here's what you can get today. Obviously, for everyone's application and the different things and tests that the product needs to be capable of doing, we'd be happy to enter in any kind of agreement with somebody to develop it.
And that brings another good question about the testing. What kind of test do you recommend, or are there specific tests for DetaPipe that the customer can actually come and request?
Yeah, I mean, if you're going to buy a pipe, you're going to probably want these three tests, which are also available in DetaPipe. You'll want a hydro test.
Okay.
You'll want a PT and RT of all the welds, and for sure the pressure boundary welds, and a helium leak test.
Okay.
Other than that, I mean, the process in itself doesn't change much like DetaClad.
Okay.
DetaPipe doesn't change any of the metallurgical properties of the raw materials we use for the cladding process.
Okay.
So if you started with zirconium 702 or tie grade 2 in the beginning, at the end, none of those properties are any different.
So it shouldn't affect the resistance of the corrosion resistance behavior of that metal.
Yeah, no change in the resistance of corrosion of the raw material for the cladding, nor any change in the metallurgical properties for the strength carbon steel either.
Okay, that's very interesting. I mean, I'm excited. When can the customers actually start ordering?
I mean, start ordering. I've always been told my manufacturing counterpart, I'm going to land something that you need to make.
Okay.
We're there though. I think we've done a lot of work over the last 2 years in the development of this product that right now, if people have a fit for DetaPipe, let's talk, because we're at that point now where we can release it to people to start accepting orders for it.
Okay. Excellent. Well, I really appreciate it, Jason.
Oh,
This is amazing. A lot of good stuff happening, and hopefully we'll hear from you, get questions, and I'll hand it back to you, Haley, for closing remarks.
Yeah.
Are there any questions that came in? I can't really see from.
So we do have one question in chat.
Okay.
In the chat, okay.
Yes.
Sorry.
So the question is, how about UT checking for unbounded zones? In reactive metal pressure vessel fabrication, it's common to want a shear test and it's common to want a UT, okay? In DetaPipe, because the cladding process takes place in the finished product form, UT isn't really necessary. Do you want to make sure that you have full contact throughout? Our process proves that you do have full contact metal to metal so that you can heat trace. You do have good thermal conductivity efficiency. UT and shear tests, we don't foresee being a test that would be needed for DetaPipe, and we don't have a ton of data on it currently.
Okay.
If it's needed, we can talk about it for sure. There's other non-destructive tests out there, eddy current testing, other advanced techniques for ultrasonic inspection. Right now, what we've produced and what we're offering are things that are pertinent to buying and selling carbon steel pipe spools.
Gotcha. So you don't envision UT as being a necessary inspection technique
No,
for DetaPipe?
I would not say so.
Okay. So another question we have is, what are the end connectors? What are these hubs?
So the end connectors are actually clad on the face of the flange, and that hub is then welded to the pipe, and then the cladding process takes place, and then we finish the cladding process. So the way to connect DetaPipe to the rest of the system is going to be with some type of flange connection.
Okay.
Currently, we're in development of different ways to connect them. But right now, the one that we've developed for a couple of people are flange connections.
Okay. Any other questions?
I think
Give it a minute.
just a quick, while we're kind of sitting here, some of the questions that if I were out there, what are the available sizes, things like that. So currently, I think we're anticipating the value proposition for DetaPipe to be kind of in that 6-inch to 30-inch nominal pipe size. I would say it's probably, in the Schedule 80 and above in terms of wall thickness. But clad is weird. Things that you would expect to be clad sometimes aren't, and things that you wouldn't expect clad to be sometimes are. And I know in vessel fabrication, there's times when you look at it on a per pound basis, and there's no reason clad should be used, but the exterior performance of carbon steel and pitting corrosion in salt water environments is better than stainless steel. And so
so it's really beyond the cost savings of not using too much of the expensive metal. It's a combination of two metals that give you an improved performance at the end of the day.
Correct. Yeah.
Okay.
I mean, and jacketed vessels are another great example
right.
of that.
Yeah.
When you need jacketed piping and things like that, DetaPipe is certainly a more
Okay.
cost-effective solution there.
So where do you produce DetaPipe? I guess is another question.
Yeah. So NobelClad being a global company, as the product continues to evolve over time and we develop the process, we will make it available from both of our manufacturing sites that we currently have, in Liebenscheid, Germany, and the other one in Mount Braddock, Pennsylvania. Currently, the process is at Mount Braddock, just based on current supply chain and customer need.
So again, just a refresher, what are the kinds of applications? You said high temperature, high pressure,
Yeah.
about the chemical environment.
Right. So obviously high temperature, high pressure, anytime you've landed at tie, zirc, things like that, at the end of the corrosion spectrum, that's where DetaPipe's going to want to be used. So where is that? Obviously, it depends on each technology and what people need and want. We foresee things where the reactive metals are currently used in pressure applications for pressure vessels. So PTA, acetic acid, MMA, methionine, epichlorohydrin, things like that would probably be places where I would expect DetaPipe to be a potential fit, depending on the different processing conditions.
That's great.
We've got a few more questions that came in. If you want to look through those.
Thickness of zirconium and titanium. That's a good question. What are the typical thicknesses for DetaPipe?
Well, yeah. So the pipe schedules that are available between 80 and above, and again, just on pure economics, are one thing, but then what's the cladding metal thickness that you can use? For us, ideally, you're using the least amount of cladding possible. Most people would design with a 3 millimeter minimum corrosion allowance. That's about the range that we're going to be offering DetaPipe cladding layers in as a starting point. Obviously, if something is needed, proven wear, things like that, we can go thicker. But in that 3 to 4 millimeter range is kind of where I would foresee the cladding layers coming in.
So can DetaPipe be used for other applications other than pipe?
That's a good question. I mean, and when we looked at it, we assumed piping would be the slam dunk, but when you get into like the pilot plant kind of size, where you're using a solid material, and sometimes those are difficult to fabricate, DetaPipe is actually a decent fit for that. I mean, they're not large in terms of volume, but they're certainly enabling, proving that clad can go into the application at pilot scale, so that when you go to a larger industrial scale, you're ready to go.
Okay. And another question related to the diameters, length of the pipes. What's possible?
Yeah, I mean, you could get something as small as a nozzle technically, but ideally you're making the fewest pipe connections possible. So we have targeted the process to be capable of cladding 6 meters long.
6 meters.
Yeah.
Roughly 18 feet, 18 to 20.
Yeah,
feet.
somewhere in there.
Okay.
Yep.
Perfect.
How is the gasket facing welded? Great question. Very, very carefully. Like the DetaClad process, DetaPipe process, a lot of how we do the joining at the ends and in the process is going to be proprietary. We will have welding procedures that will be available to people that need them. Obviously, we need to make sure that we and they have NDAs in place to protect both their process licensing and our cladding process technology. Michael, I like these questions. 9 meter. Yes. Yeah, no, these are good questions. And you know, honestly speaking, this is the first time in my 15 years of being here, and certainly for a number of decades, that NobelClad is offering a new product. Okay. We have some ideas about where this could be used. Threaten us with potential applications, and we'd love to see if it's going to fit, improve it one way or another. We think it will, but I would certainly say open up the dialogue with us and see if we can do something to help you.
This was very useful, Jason. I appreciate your time and all the effort and the NobelClad team. Actually, this is a great accomplishment, and hopefully we'll hear more from the participants and other people. So Haley, back to you for closing.
Yeah, well, just kind of reiterating what Edgar and Jason said. It's a big day for it's a huge event in NobelClad's history of us launching DetaPipe, and we just like to give you a thank you to everyone who participated today. We'd like to send you a small token of appreciation, and so you'll be hearing from me. I'll be sending an email to get addresses. And with that, we'll wrap it up. Thanks, Edgar and Jason, and have a great day, everyone.
Thank you.
Thanks, everybody.
Thanks for participating.
Have a good week.
Bye, everyone.